In the summary, it's like we go over the actual motivation, the actual overall problem, and the solution from a bird's eye view. My motivation is machine learning and really enjoying the fact that we can use data to predict future occurrences. The problem that I chose was the stock market or business, just to be able to predict how the stock market will change. The solution for that, I chose to use sentiment analysis of news articles to go ahead and attempt to project using positive and negative results to see if that actually affects the stock market, positive or negative. This is the actual project plan. We are currently very much on track. The next steps will be discussed a little bit further later on in this presentation. Here I created a very small diagram, once again, bird's eye view on the applied method, what steps we actually took in order to achieve the end goal, which is to predict the stock market. I first obtained raw data from the Wall Street Journal. I took the data, I then cleaned it through intricate parts. We just necessarily took out all the unnecessary punctuations and stuff like that. For each cell then, as an approach to actually going and creating a feature set and utilizing positive and negative news in order to go ahead and do that, it's like, which would have been a little bit more tedious, which perhaps might still have to occur, but through the actual results, I am very confident that this was actually a very decent method or a decent approach. So what happened, we utilized the actual sentiment polarity function from the text blob, which is part of the Python library, to actually find the polarity of each news article and utilize that to create a sparse matrix, which then we split into test and training data, which then we then applied Bernoulli naive Bayes, the Gaussian naive Bayes, and logistic regression, just to go ahead and give us a good baseline to see where we stand in future processes. Here we see the actual data that was or came from the actual news headlines, the sentiment polarities. In the first, we see the actual complete raw data, which is pretty much all over the place. It is scattered, not very useful, and the results of such we see, which we will see later, actually show that as well. After that, we normalize the data, which we then can see there's a nice fine line in between the two, of the positive and the negative. And with that, we can definitely do much, much more. And we'll also see later that that helped quite a bit with our accuracy. And in the end, we just took the overall mean of the data in order to go ahead and give us a box plot. We see that we have one or two outliers, which do not necessarily affect the outcome all too much. Here, from the results, we actually see the baseline using logistic regression. We have the Gaussian naive Bayes, we have the Bernoulli naive Bayes, and we have the logistic regression, which gives us about an accuracy, we can say pi times thumb, about 55%, which is not great. It's basically a coin toss, but at least gives us a baseline that we can actually move forward from. We see in the next portion, right next to the baseline of the small normalized data, once we normalize the data of the small test set, we actually achieved great results. I was very excited when I saw this. I was like, wow, you know what? This is probably the best that I've actually seen, even in comparison to other projects or other similar projects. We went all the way up to 85%. So at that point, it was justified to go ahead and move forward to make a bigger data set to utilize all the data that I actually found in order to go ahead and confirm this result. Sadly, I then fell into a little problem where I then saw, it's like, you know what? We went right back to about 57%, so we dropped immensely down in accuracy. using the larger data set, which was basically a portion which stumped me. It really stumped me, as in, as like, okay, why did it work so nicely on the smaller data set and why not so much on the larger data set? At this point, we would have to go ahead and contribute that to coincidence, and the fact that utilizing a smaller or more accurate just one stock, which was actually Facebook stock that I actually attempted to utilize, in comparison to the actual world news data that I was using, it was too broad of a data in order to determine something as specific as just Facebook. I then decided to go ahead and use an index, a larger index, which would be the NASDAQ index, to go ahead and run the same data. And long and behold, so we were able to actually achieve about a 79% accuracy. This is very, let's say, it just confirmed the actual fact that, you know what, the data was actually good, and gave me reason to actually want to move forward with the data and the data set, which then we will talk about in the next slides. So the problems was, as we just spoke about, was an actual data mismatch. I had a couple problems running with NumPy, Pandas, and scikit-learn. The learning curve in itself was a little bit difficult. And further processing of the data is like, there still definitely can be much more pulled out of the data than what we actually currently have. So for the further processing, it's like I definitely want to create a multi-class SVM to see if the actual results would confirm each other in this case. And with that, I would like to say thank you, and I'm looking forward to the final project.